All right, so now we're going to look at the next example here. Find the number of positive integer solutions to x1 plus x2 plus x3 plus x4 equals 15.
Mm-hmm.
With each xi less than or equal to 5. Okay, so this doesn't seem to be necessarily the same exact idea. x1 plus x2 plus x3 plus x4 equals 15, and it said positive integer solutions, right? Mm-hmm. So 1 less than or equal to x less than or equal to 5. So find the number of positive integer solutions to this.
Is there...
So we're going to try to find a generating function that will tell us the answer to this.
Well, I guess the one thing that comes to mind is when you multiply polynomials, if two terms have the same power, their powers add, so maybe that could play a role in the addition part.
Mm-hmm.
I mean, maybe we use something to the third because that gives us 4 terms. Well, actually, we have 5 terms because we have 4 terms with an x, and then I guess these are different numbers, maybe.
Yeah, these are all different numbers.
We have 5 terms, so maybe it's a 4th.
Well, think about what are we going to pick for this for x1? What can we choose?
A positive integer. Less than 5. So, or less than or equal to 5.
Okay.
So 1, 2, 3, 4, 5.
1, 2, 3, 4, 5. What can we choose for x2?
Same thing, 1, 2, 3, 4, 5.
What about for x4?
1, 2,
3.
3, 4, 5.
And x4. So we have the same choices for all of them, but they are constrained by this.
Mm-hmm.
Yeah.
So how does that remind you at all of the prior problem? Where we were putting juggling balls. We're allocating juggling balls, but we only had 25 of them. So the prior problem kind of looks similar,
Yeah,
right?
so I guess it's like we can allocate up to 5 balls per person, but we only have 15 balls total.
Yeah, and you have to allocate 1.
We're zoomed in.
Oh, sorry about that. Good, thanks for catching that. Okay, so can you think of what, even just for x1, what sort of the generating function would look like?
Just maybe x plus x, or z plus z squared plus z cubed plus z fourth plus z to the fifth.
Okay, so that's saying I can pick 1, 2, 3, 4, or 5 for x1. So does that give you a guess as to what this generating function might look like for the whole, that will count the number of solutions to this?
So I guess we can raise that to the 4th, and then we have to count the z to the 15th coefficient.
We take this to the 4th power, and then we look at z to the 15th, whatever that coefficient is, and that's going to tell us, it doesn't tell us anything about those solutions.
It just tells them or tells us how many there are.
Right, so like for example, 4, 4, 4, 3 will be a solution, but whatever this number is, it'll tell us how many different solutions there are. Yeah. All right, so why don't you take a look, and have we done it correctly?
It says the generating function for choosing the size of each variable is z to the 1 plus z squared plus z cubed plus z to the 4th plus z to the 5th.
Uh-huh.
So the generating function for the whole sequence is that to the 4th power.
Okay.
And it says the number of solutions is 14, choose 3, minus...
Wow, yeah, actually doesn't it say there's a different way to do it?
Coefficient of...
That last sentence says, like, by alternate methods we learned before.
Previous methods.
Yeah.
Use choosing numbers.
So there's a different way to do this that they've talked about previously in the book, but the generating function only tells us how to do it in a really nice way. Okay, so now we're going to move on to 2 problems.